subject is workshop 3, and this subject has got 2 modules. One is forging and another one is molding. So first we'll start with forging. So you have been taught about manufacturing process in your first semester, isn't it? Okay. Okay, so actually earlier the subject was in the first semester, so there is a slight change in the rescheduling of the subjects. So it would have been better if it would have been in the first semester, so that you would have been given the input about the different manufacturing processes. Anyway, so let me first give you some introduction about the basic manufacturing process. So the manufacturing process basically can be divided in 2 categories. One is called the primary manufacturing process, and another one is secondary. So under primary manufacturing process, we have got the processes like forging, rolling, molding, casting, and so on and so forth. And in secondary, you have got the machining, which is the major part, machining, where we use the machine tools to, transform or cut the material into finished goods. But here in primary manufacturing process, we have got different types of devices to transform the raw material into the finished goods. So forging is one of the primary manufacturing processes. And of course, you'll see the machine shop in your 3rd year and 4th year classes. And the main point is that, see, this type of workshop classes, this online mode of teaching is actually, I think that it is not at all, the replacement of the actual true class or offline mode class. So we expect that the university should open at the earliest, and the latest news is that probably the university is going to open. But point is that how to start the class, undergraduate class, whether we should call all these students or we'll make the groups or something like that. That is still to be decided. So anyway, we expect that the class will be started and we can start the offline mode so far as the workshop classes and all labs are concerned. So far as the theoretical classes are concerned, okay, to some extent we can make up. But so for this practical classes, it is not at all, up to the mark. Actually, what happens is that in all the lab classes, you are supposed to do some work with your own hands, and doing the work, lab class in your own hands, by your own hands, and learning, that is something different. So I think you will get that opportunity. What has happened the last 2-3 years is not at all expected. Anyway, no other options. We didn't have no other options. Have any other options? We are compelled to do this type of. We have to follow this type of classes. So anyway, we expect that the university should open at the earliest. Anyway. So I was telling about the forging. The forging will start first. So have you come across the term forging? Do you know what do you mean by forging? Any idea?
This is a manipulation of shape with application of heat and force.
Yes.
Like beyond heating over the recrystallization temperature and manipulating the shape after that.
Yes. So basically, we require 2 things. One thing we require is that the object or the raw material or the material you are going to forge is to be subjected to heat, or heat is to be applied to raise the temperature to a certain degree, and then we apply the pressure or force. So application of pressure and application of heat, the two important things in order to perform the forging. So what I will do, I will give you some basic input about the forging process, like the forging, different forging operations, then the materials that can be forged, then the forging temperature up to which you can you can perform the forging operations, then the different forging tools that are required. That is very important. So these are some of the basic points, and I will directly go to the job that you are supposed to do. And I think if university opens, then you'll have to do the job yourself in the forging shop, maybe in groups. Let me give you some basic introduction about the content of this forging. So I'm going to present the slides. I will send this PDF to you so that you can study. I will just glance through some of the important points, and you can study yourself. On forging, I have got 2 PDFs, so I will send you, and you can go through these, some of the important points. So to start with, we have 2 important terms here, smithing and forging. There is a slight difference in these 2 terms. The difference is that when you are talking about the smithing, then it is applied for some small jobs, and we use the open fire firing device. So smithing is for small jobs, smaller jobs comparatively, which can be done by hand or manually, and we use open fire hearth or open hearth. In case of forging, what we do, we use this term to refer to the bigger parts, and we have got the machine forging also. So forging can be done both manually as well as with the help of machines. Or we have some devices for applying the pressures for bigger jobs, and here we use the closed furnace. So this is the basic difference between these 2 terms, which sometimes we use interchangeably, smithing and forging, but there is a slight difference between smithing and forging. So next point is the forging materials. So what should be the property of the forging materials? Not that all materials can be forged, but the material should have some property. So by now you know what are the different mechanical properties. So one of the very important mechanical properties that is the requirement for forging materials is that the ductility. So if the material is not ductile, you cannot transform it into forged parts. So the material should be ductile. So like brittle materials like cast iron and those other materials cannot be forged. On the other hand, you have got the low carbon steel where the carbon percentage is low, or medium carbon steel that can be forged quite easily. So there are other, and most of the metals can be forged. So whether a material can be forged or not, that actually, or the degree of forgeability, or sometimes just called forgeability, or so far as the forging is concerned, the workability. So forgeability is basically the ability of the material to be forged. or the age with which we can forge a material, so forgeability. So obviously the material, one of the important property that is required is the ductility. The more ductile will be a material will be the more forgeable. So here are some, some of the most common materials which we normally use for forging to manufacturing different types of components, like most of the metals, and we have got the steels, carbon steels. Then we have got the alloy steels, stainless steels, wrought irons, copper-based alloys. So aluminium alloys, magnesium alloys. So most commonly, you see, most of the parts, the ferrous materials. On the ferrous materials, we have got the low carbon steel and medium carbon steels are extensively used for manufacturing different components in forging shops. So forgeability, I have already told you forgeability. So here is a table which shows the forgeability of different alloys, relative forgeability. So you can see most of the good forgeable materials are aluminum alloys, magnesium alloys, copper alloys, and carbon and alloy steels. So these are some of the good forgeable materials. There are some other materials which are slightly difficult and very difficult to forge. So mostly this very difficult materials falls under this brittle type of material. The brittleness increases. Then comes the heating device. So heating device, as I have already told you, there can be open hearth or closed hearth furnaces. So we have here the open hearth furnace. So here you will see in our forging shop the different tools and accessories that will be required. And if you get the chance to do the job by your own hands, so obviously you can see all the tools and accessories that is there in the forging shop. So there are the different types of harnesses. You can go through yourself. I'm not going to explain all these things. Then in here in our university, what is there is just to give you the idea of forging, not that all the tools that are used in industries are here, but just to give you some idea. But if you go in any industry which are using forging as one of the manufacturing process, you will get a lot of other advanced tools and techniques you can see. So induction furnaces may be there, resistance furnaces may be there. So those things are there. So here are some furnace, some drawings of some furnace. Next important point is that what should be the forging temperature? That means at what temperature we should raise the heat the material. What should be the temperature of the material so that forging can be done? So obviously it is different for different materials. Since we'll be using the low carbon steel as our specimen here in forging shop, so its temperature will be around 1250 degree centigrade. And for other materials, some maybe the slightly lower, say aluminium based alloys will have slightly lower temperature. So ferrous materials will have slightly higher forging temperatures, so around 1250 to 1300 degrees centigrade. So that will be the forging temperature. Now point is that how to know what is the temperature.
Sir.
Yes.
So someone is trying to join, I think.
No, actually, I told you that you should join quickly, and if they join after 15 minutes, they should not join in the class.
Okay, sir.
Okay. So the temperature. How should we know the temperature? How should we know the temperature? Actually, the temperature can be known by the color of the job. You see, as you if you place the job in the furnace, color gets changed. Initially, it will be faint red, then the redness or the reddish color will increase, like it will be blood red, then cherry red. So there's a change in color, bright red, and slowly, it will transform from orange, yellow to white. You can see it in your in our forging shop. So seeing the color of the job, the object, you can guess what will be the temperature. So when we are above 1200 degrees centigrade, it will be almost white in color, and below that it will be yellow, like around, when it is yellow, it will be around 1100 degrees centigrade, 1000 degrees centigrade. So like that. If it is just red, faint red, 500 degrees centigrade. So there's no other way. But if you want to measure the temperature, of course, you have got the optical pyrometers to measure the high temperature. So those who are working in forging shop, the persons, they can just guess the temperature, what will be the temperature. And one point is very important, where you should be very, very careful, is that if the temperature goes beyond 1200 degrees centigrade and more, it may so happen that the material may melt. So it should be very, very careful about when to take out the job and when to start forging. If you keep the job for a long time in the furnace, it may so happen that the material may be lost in the furnace because it will get melted. So so this is how you can know the temperature, of the forging temperature. So in our case, our job will be low carbon steel. It is mild steel. So the temperature is around 1260 degrees centigrade. So you'll have to, you will not fully, place the job in the furnace. Rather, you can just insert the job in the furnace around 50% or 75%. So you can see what will be the color. You can just see from outside what is likely to be the color of the job, whether it is reaching yellow or white. So that point you should be careful. Next important thing is that what are the different tools and accessories that will be there in the forging shop. There are some hand tools also, for automatic forging operations. There are machine forging, drop forgings, and other devices are also there, but we do not have here all those devices. And here we will be using the hand tools, mainly the hand tools. So let us see what are the different hand tools. One of the very important device that we'll be using is the anvil. Anvil, these tools you should know, you must know, so far as forging workshop is concerned. So anvil is one of the very important and primary device here in forging shop. So how anvil looks like, here is the diagram of anvil. So this is the anvil, you can see figure 8.3 anvil. This is made of mainly carbon steel. Body is carbon steel, and the top surface is hardened. Top surface is hardened by heat treatment, because on the top surface itself we perform all the different operations on the top surface. So it has got a typical shape. You can see on the pointed side, we call this side as horn, and we have got a number of holes on the surface. Two different types of holes are there. One is circular hole, which is known as the Prichel hole, and another is the Hardy hole. Hardy hole, it is square shaped. The cross section of the hole is square. It is because there are some other devices like fuller, then other forging tools which are to be placed here on the Hardy hole. Like the bottom fuller will be placed and the top fuller will be placed on the job. You will see it actually, and then you will perform operations like making or drawing out or something like that. So that is the use of these different holes. And of course, there is a chipping block here. So there are different parts. All the parts has not been shown here in Anvil in this particular diagram. So if you see some other diagram of Anvil, you can see the other parts also. And this the horn or the pointed part is actually used to bend the material. Suppose you want to bend the material to form some, say, circular shape. So for that it is used. Of course, there are other purposes also. So this is Anvil, one of the very important device here we use. Then you have got the swage block. It has also different purpose. We can give different shapes here also. You can make some semicircular job, or you can make some hexagonal cross section, something like that. So there are multi-purpose device. This is. Then we have got the hammers. So in your first year class, definitely you are aware about different types of hammers. We have got the ball peen hammer, straight pin hammer, and all that, cross pin hammer. They are also used. We have got the tongs for holding the hot job. Tongs are of different types. We'll see it. These are the different tongs. We have got the flank tongs, ring tongs. We have got the straight lip, flute tong, gat tongs, flat tongs, and so on and so forth. So we have got the tongs. Then we'll use the chisels, hot chisel, cold chisel we'll be using for performing different operations. Then we have got the fullers. Fullers are basically used for making purpose. That means for reducing the cross section of the job. Then we have got the flatters, set hammers. You can just go through this the use of these tools here. We have the punch and drift. Punch is basically to making the hole, and the drift is used for increasing the or making a larger hole. So punch and drifts are also used. Next comes the different forging operations. So these are the six basic forging operations. One is called the upsetting, then drawing down, or sometimes it is called drawing out, setting down, bending, welding, cutting. Then punching and fullering also. So here fullering, okay, it's punching and fullering. So total 8 operations we have. So upsetting is basically upsetting, or sometimes it is called heading. Upsetting and heading, same terms. So upsetting is basically increasing the cross section. Suppose you have got a cylindrical job and you want to increase the cross section. So you place the job on the anvil, you hammer it, and the cross section will be something like this in the like diagram A. And if this shape will be when you have the whole portion is heated, will be this shape, and part B will be when you have heated 2 ends and not the central portion. So obviously it is clear that the central portion will not be deformed because it is cold. And in C part, you can see the lower portion has been heated, not upper portion, and the D part, it is central portion. So there are different ways. So where you want to increase the cross section, accordingly you'll have to heat that particular portion and do the operation. So this is called the upsetting or heading. Then you have got the drawing out operation or drawing down. Suppose you want to increase the cross section. So this is the way. Slowly you have to increase, slowly. So you will be shown it. Unless you are shown, actually in the forging shop, all the technicians, they will help you, or they will first show you, demonstrate to you how to do the job, and then you will do the job. So drawing out operation basically is the decreasing the cross section and increasing the length. Just reverse process of heading or upsetting operation. Then you have got the setting down operation, punching operation, so bending, all this you can see. And then you have the joining operations also. So as you know this, by forging also we can join. Joining, basically we use the welding for joining, but forging can also be used for joining. As you can see, we have got the lap weld, butt weld, or sometimes T or jump weld and V-shaped weld. We are calling this forge welded joints. You must have seen the welding shop in your first class, so you have seen the different types of welding processes. But here in forging shop also you can join two different parts, which we call the forge welded joints. Then cutting operations are there, fullering. So as I have told you, fullering is basically used for necking purpose or reducing the cross section. So some examples here. Suppose we want to, here one example, this is making a hexagonal bolt. Suppose you want to make a bolt. Just to give you an idea, you will be given a cylindrical job, and that is to be transformed into the finished hexagonal bolt. So what is to be done is that basically you'll have to heat at one end, and then you will have to perform the upsetting operation as has been shown in this diagram, upsetting operation. And once you have increased the cross section at one end, then you'll have to place it into a Swiss block. It is a form of Swiss block, and you have to make it a circular one. The top should be made circular cross section with larger diameter, as it has been shown here. So one, it has been transformed into a circular one. Then with the help of Swiss block, we can make the head as hexagon, as it has been shown in this diagram, and ultimately we can make it into the hexagonal bolt. Of course, there are some other operations involved. Just to give you an idea how a raw material can be transformed into different shapes using different forging tools and different operations. Then this is also making a cold chisel, another example. So here hexagonal or say octagonal shaped one part is there, and that can be transformed into a pole chisel like these in forging operations. So these two are just examples, but the job that you will be doing, the forging shop, it is slightly different. Now I'm going to discuss that particular job which you will do in our forging shop. So other points you can just go through. There are other types of forging operations are also there. You can go through. So there are power forging also, pneumatic hammers. There are different, mainly hammers which are used are pneumatic one. So these are used when large size jobs are to be forged. Definitely some machines are to be used. We cannot perform the forging operations manually. So they are used in industries. So here, let me show you the job that you will have to do. You'll have to do in our forging shop. So can you see the slide?
Yes, sir.
Okay. So this is the job which normally our second year student, they themselves complete this. This is one of the jobs. This is the first job that we give to our the second year students, mechanical engineering. So this name of the job is drawing out operation. Name of the job is drawing out operation. And the material is mild steel bar. And the shape of the job is square cross-sectional area, and the side length is ½ inch, and the length of the job is 4 inch. So this is a square job of length 4 inch, and the cross section, the edge length of the square edge length is ½ inch. So that is the raw material here. And this raw material is to be transformed into a finished job. Let me show you the finished job. This is the finished job. The last one, the number 6. This is the finished job. How the finished job looks like? Actually, it has got one end covering about 4 inch length, but the cross-sectional area will be much lower. Cross-sectional area will be much lower. As you can see, the edge length is 3 by 8 inch. 3 by 8 inch. On the other hand, there will be another portion that will be of circular cross-section, and the diameter of this circle will be 1 by 4 inch. So that is the final shape that is to be given, and this is to be done by you. Of course, there will be people to help you, but you'll have to do it yourself. So raw material I have given you, and this is the finished job. And we have discussed about all the devices, and you will require the help of furnace, you will heat it, you will require the different devices, the different operations that are to be performed, that is given in the table sequentially. So this is the first operation. First operation is that you'll have to hit about 70% of the job, or you'll have to place the 70% of the job, or about 3 inch, in the furnace. So heat one end of the bar to about 1260 degrees centigrade, and you can know the temperature by seeing the yellow color, or to some extent white, in between white and yellow. And you will use the tool, the furnace, Smith's hearth, or the device. So this is the first operation. You have to heat it. But before that, starting the furnace and all that, there will be people to help you. And then, second, what we'll have to do is that first you'll have to make this 3 inch length heated portion into a square shape of lower cross section. So this final cross sectional length, that means one end you are making 3 by 8 inch side square. So basically, what operation you will do? You will perform the drawing out operation. So drawing out operation means you are reducing the cross section and you are increasing the length. And what are the tools you are using? Definitely you will require the anvil, tongs and hammer. Anvil, tongs and hammer. And you will be given a gauge. Gauge will be used to check whether you are close to the dimension 3 by 8 inch. And they will have the steel rule also to measure the length. So this is the second operation. Although it looks quite simple, but when you will be doing it, it is not so simple. And that will give you some sort of experience how to do it. So this is the second one. Then the third step is that now you hit the other end. So repeat the process too for the other end. Same tools are used. And when you will be transforming this into a square bar of smaller cross section, its length will be, as you can see, around 7 inch slightly more than 7 inch. To be exact, the dimension will be 7 by 64 inch. So the dimensional accuracies are also important. Now, problem is that when you will be hammering the job, if you hammer more, and the cross section becomes less than this, 3 by 8 square, then there will be a problem. If it is not, the job is not accurate, obviously credit will be less credit will be given to you. So you should be careful. You should be careful about how much to hammer, and you'll have to definitely see, and with the help of or check with the help of the gauge whether you are close to your required dimensions. If it is too less, definitely it will not be, some discrete. There will be some discrete. So you should be very, very careful about that. So this is the third step gives you a complete a job of a bar of square cross section of length about more than 7 inch. And next operation is the fourth operation, that is called the necking. Necking means basically reducing the cross section at certain point. Some point. So if we look at our final job, you see at one end we have 4 inch length of cross section at 3 by 8 inch side. So we will mark that particular point with the help of steel rule, and we'll place the fuller here. Of course, fullers are used in pairs. There will be bottom fuller and top fuller. So the bottom fuller will be placed on the hardy hole of your anvil, and the top fuller will be on the upper side of the job, and you'll have to hammer. So that at that particular point there will be a localized deformation, and the cross section will be smaller. Of course, you can see, if you see in the video that I have given the link, you can have the idea. So this is, all the necking operations, and the tools that are used: anvil, tongs, hammers, fullers, top fullers, and bottom fullers. So this operation is called the necking. And next comes the fifth operation. So the right hand portion is to be again drawn out to reduce the cross section further, and finally the cross section will be 1 by 4 inch square, as it has been shown here. And so the tools similar tools that you have used earlier, anvil, tongs, hammer, and of course you will check with the gauge how far you are close to your dimension. So once you have made this square cross section, next you come to the sixth step, that is, you perform the circular cross section. So initially this square is to be made, this square shape is to be made into an octagon. How they will make it? Because they will transform diagonally. So instead of, when they are performing this hammering diagonally, what will happen? It will be transformed into octagon, and finally then it will be easier to transform it into a circular cross section. So this is the process in brief I have told you. Now when you will do by your own hand, you will face some problem, and when you are facing the problem, actually you will learn something. what is the problem happening. So that is the interesting point, that when you will be doing by your hand, you will make some mistake and then you will learn. So that is the point. So that is everywhere. Unless you make mistake, you won't learn. So you will make some mistake. In your machine shop also, you will be given some job. You will be told to do something. You will make some mistake and you will learn. So that is the idea of all these labs actually. You will when you are doing by your own hand. So what we expect is that if everything goes well, everything is normal, you are able to do the job in this workshop, then apart from the theoretical study, the study material that you will study definitely. If you want to refer some other books, you can refer. And then you'll have to do this job yourself, and job will carry some marks. When we will be evaluating, we'll give you some marks, and in fact, maximum percentage of marks. Suppose you have got 100 marks, maybe more than 50-60% marks will be given on the job. Then you have got the report writing. You'll have to write some report. Some of the questions that will be giving, that is to be written in the report, and ultimately you'll have to appear for the viva. So that is the mode of evaluation: doing the job, submission of report, and final viva. So that is how these workshops are, done. So this is the idea, basic idea I have given, and hope that I have come to know that from tomorrow itself the university is going to open. Now, point is that whether all students will come or will call the students in groups, that is not yet decided. I think it will be decided shortly, and we expect that you will definitely get a chance to do your job in our forging shop and other workshops. Now, with this, I don't want to extend, because these theoretical lectures, better it will be, convenient for us to explain everything in our lab, in our workshop. So expecting you to meet in the workshop in the next class, probably. Today I will stop here. And let us see how far we can conduct the class in offline mode. Okay, any question from your side?
Sir. Hello, sir.
Hello, yes.
স্যার বলছি যে এই জবটা করার সময় অ্যাকুরেট মেজারমেন্টগুলো আমরা করব কি করে?
You have the gauge.
7/64 যেখানে
You have got the gauge. Unless you see the gauge, actually there is a gauge. You know what is the difference between gauge and measuring device? Gauge দেখেছো? Have you seen gauge?
গেজ মানে তো স্যার ওই ফুটও থাকবে না, একটা স্কোয়ার।
স্যার গেজে স্যার মেজারিং ডিভাইস গুলো তো গ্র্যাজুয়েটেড থাকে, গেজে গ্র্যাজুয়েটেড থাকে না।
এখানে গ্র্যাজুয়েটেড থাকবে না, জাস্ট টু অ্যাকচুয়ালি গেজ কি হয়, নো গো গেজ, নো গো গেজ। মানে তোমার একটা ধরো ওটার একটা স্ট্যান্ডার্ড যে গেজটা থাকবে, দ্য গেজ উইল কন্টেইন দ্য হোল অফ অ্যাকুরেট ডাইমেনশন। মানে সাপোজ দিস ইজ ইয়োর দিস square shape of 3/8 inch. So ठीक exactly this shape, size of the hole will be of this shape, and also there will be a circular hole of this diameter will be around 1/4, around 1/4 inch. Now the point somebody was asking that how to maintain this 7/64 inch. Point is that not exactly, but you should be as close as to this dimension. যতটা কাছাকাছি সম্ভব, যার খুব কাছাকাছি হবে সে বেশি নম্বর পাবে, as simple as that. আর যার ঠিকঠাক হবে না, দূরে থাকবে, তার নম্বরটাও কম হবে। You should try to be as close as possible. এবার তাতে যা হবে হবে। ঠিক আছে, বোঝা গেল?
Yes, sir.
Okay. So, any other question? If no question, then I can stop. Hello. So, if do you record the PDF I have shown you, or you can go through some books. Can you hear me? থাকতে পারে আরো ভালো এক্সপ্লেনেশন থাকতে পারে। What I tell you that you better refer a book, textbook. ওয়ার্কশপ টেকনোলজি তুমি চ্যাপম্যানের দেখতে পারো, বা আরো অন্যান্য অথরের বই আছে। So many workshop books are there. So you refer any workshop book and read this chapter forging. এখানে আরো ডিটেলস পাবে, ডিটেলস আরো ডিফারেন্ট টাইপস অফ, like I have shown you the anvil, diagram of the anvil. Not all parts have been shown here. তো ওই বইগুলো দেখলে আরো তোমরা ভালো করে বুঝতে পারবে। In fact, when we will be preparing the report, I will give you some questions later on. I'll give you some questions, some basic questions related to forging this topic. So the answer of those questions are to be written in the lab sheets to prepare the report. So there will be you'll have to make the drawings, and you'll have to label the different dimensions, different parts. You know, suppose you are drawing the anvil, so you'll have to show the different parts of anvil. Suppose you are drawing the swage block, you will show the different parts. So it is better, definitely you have to refer some other books. The PDF which I have will not contain all the things. Okay.
Yes, sir. Sure, sir.
So should we stop today? And ক্লাসে তো তাড়াতাড়ি আসতে হবে সময় মতো। I had opened this thing link around 5 minutes before our scheduled time, and somebody are trying to join after 20 minutes. It is not expected. Okay. Thank you all.
Hello, sir. Hello, sir.
Yes, yes.
স্যার বলছি আমি আপনাকে একটা মেল করেছিলাম, আপনি পেয়েছেন ওটা?
কিসের ব্যাপারে?
স্যার আমার মেডিকেল কন্ডিশনের ব্যাপারে।
মেডিকেল কন্ডিশন তোমার কি আছে, অসুবিধা কি?
আমার স্যার এই শনিবারে অপারেশন হয়েছে একটা, আমি স্যার মানে অফলাইন ক্লাস স্টার্ট হলে যেতে পারবো না 6 থেকে 8 সপ্তাহ মতো।
মেডিকেল গ্রাউন্ড থাকলে তো কিছু করার নেই, সে তুমি তাহলে পরে ইয়ে করে নেবে, কথা বলে।
ঠিক আছে, আমি মেলটা করে দিয়েছিলাম আপনাকে, আপনি যদি একটু দেখে নেন তাহলে ভালো হয়।
ঠিক আছে, আমি দেখে নেব।
ঠিক আছে, থ্যাংক ইউ।
Okay, then I am stopping today.